Dear students, we are doing the practice on the examples of capacitors. See the another example which was asked in AIEEE 2008. Right? See the example. Another example. The two mediums, it is a K1, it is K2. The width is D by 3 and the another width is 2D by 3. Means the K1 is the dielectric medium up to the width D by 3 and K2 is the dielectric medium up to the width 2D by 3. The values of K1 and K2 are given. K1 equal to K2 equal to K1 equal to 3 and K1 equal to 6. This is given to you and this question is asked in AIEEE 2008. Right. So already we have solved this such type of numerical, but don't worry, we will see once again. And one thing it is given, where capacitance of the capacitor when there is a air medium is present, that capacitance is 9 microfarad. Right? C equal to, when the air medium is present, epsilon 0 A by D, and that is equal to 9 picofarad is given, right? Picofarad is given. So these are the given things. Now we are going to solve this example. First of all, we will write what is C1 and what is C2. First of all, simplifying the diagram. Capacitor 1, capacitor 2. It is C1, it is C2. Width is D by 3. The width is 2D by 3. Area is A, area is A. Dielectric constant is K1, dielectric constant is K2. These two capacitors are in series. The question is find out the equivalent capacitance of such a combination. Okay. First of all, we will calculate C1. We know that we have calculated the C1 lots of times, so we will write directly. Epsilon 0 K1, right? A is remains as it is and it is D by 3. So D by 3. Correct? So finally 3 epsilon 0, instead of K1 what we will write? K1 equal to 3. So here we will write 3. 3 3 is 9. We will write 9. 9 epsilon 0 A by D. But epsilon 0 A by D also we can write it is a C. Right? Epsilon 0 A by D means what? It is a C. So we will write it is a 9 remains as it is. Instead of this we will write 9C. So C1 equal to what? 9C. Okay. Capacitance of the capacitor will be, C2 is the capacitance of the second capacitor. We will write epsilon 0 K2 A remains A, right? Area of capacitor, and D is what? It is 2D by 3. 2D by 3. Correct? Putting all the values, epsilon 0 as it is, instead of K2 we will write 6. So 6 3s are 18. So 18 epsilon 0 A by 2D. 2s are 9. So it becomes C2 equal to 9 epsilon 0 A by D. Epsilon 0 A by D is again C. So 9C. C2 is again, it is a 9C. Now what is C equivalent? C1 and C2 are in series. So what is the equivalent? C equivalent equal to, we will write C1 dot C2 divided by C1 plus C2. Putting all the values, C1 equal to 9C, C2 is also 9C, C1 is 9C plus 9C. So here 9 9s are 81, C square divided by 9 plus 9, 18C. this C get cancelled. What we can write? 9 9s are 9 2s are. So it becomes 9 by 2, right? And C is remaining. Correct? But what we know? 9 by 2. What is C? The C is given to you. C is 9 picofarad. So we will write 9 picofarad. So it becomes, right, 81 divided by 2. 81 divided by 2 will becomes 40.5. So 40.5 picofarad is your final answer. So this is the question from AIEEE 2008. Correct? Now moving towards the next question and changing the type. Okay, see. See students, the diagram is given to you. Diagram is like this. Simple question we are taking first. This is the diagram. Battery is connected. It is of 6 volt plus minus 6 volt. Battery is connected. Current I is flowing. It is C1, it is C2, it is C3. It is of 10 microfarad. 10 microfarad. It is of 5 and 5. 5 microfarad. 5 microfarad. The question is, find the equivalent, find C equivalent of this diagram. Second question, voltage drop across each capacitor. Voltage drop across each capacitor. And third question, find charge on each capacitor. Charge on each capacitor. These are the 3 questions asked to you. First of all, we will try find the C equivalent. It's very simple. 3 capacitors are there, C1, C2 and C3. First of all, what we will understand over here, the terminal is connected over here, right? And it is also connected over here, right? C. And the next terminals are connected over here, right? So C2 and C3 are in parallel. Here from the diagram, C2 and C3 are in parallel. So C dash is the equivalent capacitance between C2 and C3. That will be using the formula for parallel combination, that is C2 plus C3. It is 5, it is also 5. 5 plus 5, it becomes 10 microfarad. C dash equal to. Right? So the diagram will be like this. Diagram will be this. It is C1, right? And it is C dash. Correct? Here it is a battery of 6 volt. Like this. Now C1 and C dash are in series. So C equivalent of this, that will be C1 dot C dash divided by C1 plus C dash. What is C1? It is given, that is 10 microfarad. into what is C dash, that is again 10 microfarad, correct. What is C1, that is 10 plus 10, so you will get 5 microfarad. See, let us see what is happening over here. It is of 100, it is of 20, so it becomes C equivalent equal to 5 microfarad, 20, right? 5 we can write. So this is your final answer for the C equivalent. It is 5 microfarad. It is your answer. Now voltage drop across each capacitor. For the next question, voltage drop across the each capacitor. Okay, erasing this. After solving this, what will you get? That is 10 microfarad. So we will write, or we will draw the diagram like this. It is C1, it is a C dash, C1, C dash, correct. It is of 10 microfarad, it is also 10 microfarad. The battery is connected over here. Here it is the battery. We can understand it is a 6 volt battery. Voltage drop across the C1, that will be suppose V1. V1 is the voltage drop across the first capacitor C1, and here we will write voltage drop across the C dash, that is will be V2. C dash is made up of C1, C2 and C3. Here C2 and C3 are in parallel. So voltage drop across the C2 and voltage drop across the C3 will be same, because C2 and C3 are in parallel. Okay. So here charge on the first capacitor will be Q and charge on the second capacitor will also be a Q, because C1 and C dash are in series. As we know that in the series combination, charge will not divide, only voltage will divide. So voltage across the first capacitor is V1 and voltage drop across the C dash will be V2. So finally what we can write over here? So V equal to, we can write V1 plus V2, V1 plus V2, right? So V equal to 6 volt. What is V1? We don't know the value of V, but C equal to Q by V we can write. So V equal to, what we can write? V equal to Q by C we can write. So here V1 equal to what? Q divided by, instead of C we will write C1, correct. For the V2 again we will write Q by C2. C2 means what? C dash, that we can write. Take the common thing outside. Q remains as it is, 1 by C1 plus 1 by C dash, correct. Okay, next putting the values. 6 equal to, Q remains as it is, 1 by C1 equal to what? 10 microfarad plus what is C dash? It is again a 10 microfarad. So 6 equal to Q as it is, 2 times 1 by 10, it becomes 5. 6 equal to Q divided by 5. So Q equal to, we can write 30 into 10 to the power minus 6, because it is 5 microfarad, correct. So that's why Q 10 to the power minus, Q means what? Charge on C1 capacitor and charge on C dash capacitor, right? So this is 30 into 10 to the power minus 6 is the charge on the C1 and C dash. Now we are going to find out what is the voltage drop across the C dash and C. Here dear students, we can see that the first capacitor is of 10 microfarad it is also 10 microfarad. The capacitance of the both capacitors is same, so they will equally divide the voltage. So we can write 3 volt will be the voltage of the first capacitor and 3 volt will be the voltage of the second capacitor. And also we can solve from this also. See here, what is V1? V1 equal to what? Q by C1. So you just put the value of Q, put the value of C1, you will get the answer, right? It will becomes a 3 volt. So in this way you can calculate the voltage drop across the first capacitor and second capacitor, right? First capacitor and second capacitor. So this is the type of example. Now we will see the next example. See, simple example we are taking. First of all, see the next example. It is of 3 microfarad, it is of 3 microfarad, 3 microfarad, 3 microfarad, it is of 2 microfarad, and it is of also 2 microfarad. Find the equivalent capacitance between A and B. How we will solve this, right? Okay, see. Here we will name the capacitors C1, C2, C3, C4, C5, C6. You just observe the diagram first of all. See, the first terminal of the C2 is connected over here, and the next terminal is connected to another capacitor, next terminal is connected to another capacitor, and the next terminal is connected to the another point. So from the observation we can consider C2, C3 and C4 are in series. Here C2, C3, C4 are in series. So diagram will be like this. 3 microfarad capacitor, 1, 2, 3. After solving this you will get or C dash, right? C dash is the equivalence of this C2, C3 and C4. C2, C3 and C4, right? So these are the points. So what is C dash? C dash is equal to what? These 3 capacitors are in series combination. So we will write like this: 1 by C dash equal to 1 by C2 plus 1 by C3 plus 1 by C4. So 1 by C dash equal to, what is C2? It is 3 microfarad. What it is? 2 microfarad. It is of 3 microfarad. So 1 by C dash. Taking the LCM, it becomes 6. Right? So 3 2s are, 2 3s are, it becomes 3 5 7. So 1 by C dash equal to 7 by 6. So C dash equal to what? 6 by 7. Right? So this capacitance of 6 by 7 microfarad. Correct? Here it is. So these 2 capacitors are in series. These two capacitors are in parallel. So solve this, you will get C double dash. So diagram will be like this. After solving this is a 3 microfarad, right? After solving these two capacitors, you will get the C double dash, right? And this is also 3 microfarad, right? So 3 microfarad, C double dash and 3 microfarad are in series. So in this way you can solve. The remaining example you just take it as a homework, right? If any query arises, you can comment me in the comment box, right? So in this way you can practice the more and more examples. In the next video we will take the new examples. Thank you.